Okay, in this example here, we've got this vector space G defined by the set. We've seen it before. So the functions of theta is isomorphic to R2 under the map given here. Now, so in order to show that this is isomorphic, we have to check the conditions. So let's start with condition 1. Condition 1 is we have to check to make sure it satisfies one-to-oneness and onto. Okay, so let's talk about one-to-oneness. Now remember, a relationship is onto, or excuse me, the correspondence is one-to-one if for every element in the domain there's exactly one element in the codomain that it maps to. Okay, that's the definition of one-to-one. Now how do we write that? How do we prove that mathematically? Well, or algebraically? Well, we would start by saying, okay, what we're saying is that how do I want to write this? We want to write, I'll write it this way. F of A equals F of B. So let's say we have that relationship. Okay. And so the idea of one-to-oneness is we want to verify that if we have this, we want to prove that this is true only when A is equal to B. So since we're talking about vectors, well, we're seeing the same thing in algebra. So this is true whenever this is true. Or only when, not whenever. Well, let's be concise. So only when. Okay, or you could think about this. As an only if. Okay? But okay, so what does this mean? Well, that means that what we're going to do is we're going to start with this and we say, okay, if this is true, that will lead to this being true. Okay? So that's the way we show one-to-oneness. We start with this and we show that it leads to this. Okay? Same thing that we've done in algebra, same thing we're going to do here. So let's do it. Okay, so let's take let's start with this. Let's start with F of A1 cosine theta plus A2 sine theta equals F of B1 cosine theta plus B2 sine theta. Okay, now we're going to apply this mapping to both of them. So this leads us to what? Well, this is going to give us A1, A2 is equal to B1, B2, and of course, this leads to A1 is equal to B1, and A2 is equal to B2. And why is that? Because two vectors are only equal if their corresponding components are equal. And so, voila. The function is 1 to 1. The correspondence, I should say, is 1 to 1. Okay, now, what about showing that f is onto? So in this case, remember, we have to show, for onto, we have to show that every member in the codomain is an image of something in the domain. Okay? So, let's do it. So how do we do that? Well, we're going to take any member in the codomain. So this is the codomain. The set of all R2 is the codomain. So we're going to take any particular value in the codomain. So let's start with xy, right? And then we're going to note that it is the image of f of x cosine theta plus y sine theta. So this is the image of this. So that's one thing to notice. Oops, got it backwards. Now we're going to verify, okay? So this shows onto, right? Because we can see that this is, any vector of this form is going to be the image of a vector in this form, okay? So it's obvious that it's also onto, the mapping is onto, okay? So now that's the first condition. Now if going on to the second condition, we want to show that structure is preserved. Okay, so well, let's start with addition. Oops, I didn't want to erase that. But anyway, I'll trust you guys wrote it down. Okay, so let's start with addition. So, you know, let's do f of a1 cosine theta plus a2 sine theta plus b1 cosine theta plus that. All right. This is now, we're just going to simplify this, right? And so all we're going to do is, because it's a bunch of sums, right, we can use the commutative law, or the commutative property. So this is going to equal this. right? So I'm just going to match up the like terms. So we got cosine theta and cosine theta here. So we can drop the parentheses, the inside parentheses. And so I'm going to make this into A1 plus B1 cosine theta plus A2 plus B2 times sine theta. And now I'm going to apply the mapping. And so the correspondence tells me that the image is going to be A1 plus B1 and A2 plus B2. Right, but we're not done. So now what I can do is this is going to be split off. This is going to be the same as A1, A1, A2 plus B1, B2, which is the same. Again, I can work backwards, right? Well, not backwards, but I can keep going. It says, well, this is the same as this, right? So that's equal to f of what? A1 cosine theta plus A2 sine theta plus the function of B1 cosine theta plus B2 sine theta. And so that's it. We're done with that one. Now, what about scalar multiplication? Well, that's going to be similar. Let's do the same thing. So let's take f of r times A1 cosine theta plus A2 sine theta, which is equal to the function of r times A1 cosine theta plus r times A2 sine theta, which is equal to, now we're going to do the mapping, that's going to be r times A1, r times A2, and again we can pull out the r, which is equal to our final answer, which is going to be f of A1 cosine theta plus A2 sine theta. And so scalar multiplication is also preserved. And so with both of those conditions verified, we know that f is an isomorphism, and we can say that the spaces are isomorphic. So in other words, we can write G is isomorphic to R2. And that's it.